To those who missed, I kindly request you you follow the last session because last session included some calculation numbers and a bit of introduction. So you will check that recording about t-test and z-test. Hypothesis testing revision 1, you will check and follow. You realize that we handled this question. And when you're following colleagues, you realize that I try to put chapters on those recordings. So if you have already followed, let's say this question, you don't need to again, maybe if you want more to do a recap, but if you realize that you have already followed, then you just check in the chapters and see the area you have not yet followed and just follow that specific area. Okay? So I want to again, we do this number very fast. We do this number very fast. And we push to other questions. So this question is all about also confidence interval. And you realize that last time I told you, whenever you're dealing with a question related to confidence interval, basically here you don't need to ask yourself whether you're dealing with two-tailed test or one-tailed test. Whenever you're just determining, whenever you're just looking for confidence interval that is like range, we don't need to worry about one-tailed test or two-tailed test. Just know with confidence interval, it is always two-tailed test. It is always two-tailed test. So what will happen is you interpret the question like this one. They are telling us that a factory manufactures a certain type of strings used for skipping exercise. In order to ensure the quality of the strings, a random sample of 10 pieces was selected and their breaking strengths were measured in newtons. You have results, and these results sometimes help you to determine sample mean or variance or standard deviation, especially if you're not given, let's say, this sample mean, and if you're not given this variance. You need to recall that in statistics, whenever you're not given grouped data, then there is also some methods we use actually to get sample mean and sample variance, sample standard deviation for ungrouped data. This data is not grouped. So I believe from your statistics, by now you should be knowing how do you handle grouped data and how do you handle ungrouped data. Okay? So here we have the sample mean, we have the variance, and they are telling us that we assume that this random sample was drawn from a normal distribution with an unknown population mean, which is new, then and also unknown population variance, which is this one. So you recall that we said this is the question 1, Roman, that is Roman what? Roman 3. With confidence interval, you recall that I said with confidence interval, basically what you're interested in is range. You need lower limit and upper limit, full stop. And you need to know that this range you're trying to find out is actually based on the population mean. This is based on population mean. Whereby we say that with population mean, it is denoted as new. It is denoted as new. Okay. Then sample mean is denoted as X bar. When the sign for population mean is new, then the sign for sample mean is X bar. Okay, so how do you get the confidence interval? You need to first know whether you are dealing with Z-test or T-test. And how do you know that? Look at your N. If N is less than, if your N is less than 30, then as a must, you must use T-test as a must. But if your N is greater or equal to 30, then you use Z-test. So we need to first understand what is our N here. What is our N? How many items are you dealing with? And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 items. So our N is 10. Our N here, our N is 10 for this question. N is equal to 10. And since we have confirmed that N is equal to 10, it means that N is less than 30, and we are going to use T-test. So using T-test, what is the population mean range? You need the interval for population mean. And that we had the formula, you can recall, when you're dealing with only one sample. When you're dealing with only one sample in the question. One sample, stroke one mean in the question. So this is your standard error. That is standard deviation divided by root n. Kindly let's maintain this. Whether you are using Z-test or T-test, and you are dealing with one sample or one mean, maintain this formula. Are we together, colleagues? Now, we need to ask ourselves, are we given standard deviation in the question?
No, we are given variance.
So we need the standard error, which will be equal to, since we have variance, remember that to get standard deviation is square root of variance. So we are going to take square root of variance. Then we divide by also root n. We divide by root n. So what do you get? Root variance is what? So just press on your calculator and tell me the answer. And colleagues, some of you who are not using calculators, please, you will get challenges in an exam. You will get challenges. It's not only about just seeing things. You need to get the calculator and we do these things together. You get used with how the calculator is actually used. What is variance in the question? The variance in the question is
It is
actually
1.58.
1.58. Here we put 1.58. Then what is our n? Our n is 10.
10.
So what do you get?
0.3975.
This is 0.3975.
75.
We can round off to 4 decimal points at this point. All of you, do you have this? If root 1.58 divided by root 10.
Yes.
Perfect. So once you have, remember now in your formula, what do you have? You have standard error. This X bar stands for what?
For mean.
This is a sample mean. Sample mean, that is X bar. And in the question, X bar is given as what?
69.1.
This is 69.1. So it means that on our formula now we have X bar, that is 69.1. We have standard error, that is 0.3975. Then we need now T alpha. How do you get this T? We must use the table. We must use the T table. But I recall that I said, as you use the T table, actually, what you are trying to as the T table, we say that we need two things. We need V, that is degree of freedom, whereby we said that V is equal to what? N minus 1.
1.
V10 minus 1, and our N is 9. Once you get V, now we need the standing, we need our proportion, we need our alpha. And the fact that with confidence interval we are dealing with two-tailed test, it means that based on our question, this is, we are given 95%. Recall what I said, if it is 95%, that percentage is called what?
Confidence interval.
That is confidence level. 95. The higher percentage is always the confidence level. And the lower percentage is the level of significance. And as we do these numbers, we are interested in level of significance. So it means that here, if you're given a confidence level, this is confidence level of accuracy. We assume that this is level of accuracy and it is 95%. What about the level of the percentage error? That is significance level.
95 minus 100. 95 to get 5%.
This is 100% minus 95. The lower percentage is always the significance level. So that is what? 5%. 5%. Colleagues, if I talk about something and you need more clarification, don't follow others. Just say me, I need more clarification here. You are in a room alone, but you must understand. So don't just keep quiet when things are not clear. Okay, so the fact that we are using two-tailed test, we need to divide this by what? By 2. Since I said that every time you're dealing with confidence interval, or when you're dealing with range, then actually what you're dealing with is the two-tailed test, because you don't know whether your figures are higher or lower. Just you are there, you are trying to get the range, you are trying to get the starting point and the ending point. So in that saga where you are not sure in the position to stand, then that one must be a two-tailed test. That's why you always find that with range, with confidence level, as we determine the confidence level, rather confidence interval, as we determine the range, it is always two-tailed test. And once you confirm that it is two-tailed test, before you go to the table, you get 5% divided by 2. That is 0.05 divided by 2. What do you get?
0.025.
That's 0.025.
0.025.
Okay. And since we are dealing with t-test,
We should have.
we stop here. We don't get 0.5 minus this. If we are dealing with z-test, we proceed the next, after dividing by 2, we proceed to the next step. And the next step is to get 0.5, then you subtract what? This one. But if you're dealing with t-test, you stop here. Once you stop on that step, then we go to our table and get what we call value from the table. We get value from the table. So we go to our T table. It will always be given in your question. This first table is a normal distribution table, that is Z table. Then in an exam, you always find that the next step, the next table is the chi-square table. Then the third table is t-test, t-distribution table. So this is our focus. You see here with t-distribution table, we are dealing with V, but with Z table, there is no V anywhere. So it means that you're going to stand. What is our V? Basing on our question, what is our V?
9.
Our V is 9, okay? And we are looking for which proportion, which probability we are looking for, which Q?
0.025.
0.025. Now, colleagues, I also want you to observe here. Are you seeing what we have here? They are telling us that use Roman 1. Upper row for one-tailed tests. Then Roman 2, lower row for two-tailed tests. Now, what does this one mean? You see here, you have, this is upper row. This is upper row. Then this is lower row. When you observe this, you have upper row, you have lower row. Lower row is for two-tailed tests, then upper row is for one-tailed test. And remember, we are using what in this question? We are using two-tailed test, isn't it? So what does this one mean? You are going to first come here on the lower row. Observe whether you have 0.025. If it is not there, then it's when you can just come here up. Note the difference. If you observe down and you see that you don't have the value you are interested in using two-tailed test, then you go up and observe whether that value is there. But before you go to upper row, first verify, first confirm whether actually on your lower row you have that value. And we see that on our lower row, there is no 0. What? 0.25. It is not there. So it means that we can rely on the upper row. So we have 0.025. Okay. Then look for the meeting point where 9 meets 0.025 column. You take that value, and when you observe, the meeting point is here. Our V is 9, then our proportion is 0.025. So we are taking what? We are taking this. So this is our value from the table, 2.262. That is the one we have. So here we are saying it is 2.262. Are you all clear about using T distribution table?
No. I'm seeing a different figure.
You are seeing a different figure.
Yes.
This is 9, eh? V. Remember, our V is 9, isn't it? Then we are interested in a column for what? 0.025. When
Yes.
the meeting point is here.
I've seen it. I had taken 0.0025.
You just take the figure. You just take that meeting where you have the meeting point. That is the figure you should record. Are you now okay?
Yes, I've seen it.
Perfect. What about others? Are you all okay? Rachel, are you okay?
Yes, I'm okay.
Okay. So this is now it means that we have everything we need. This is our formula. So it's a matter of substituting in our formula. So it means that here our population mean will be equal to our sample mean is equal to, this is mu. This is mu. It will be equal to, what is our sample mean? Our sample mean is this one. Then we erase or add the what is our value from the table? It is this one, 2.262. Then times our standard, because the formula is this one. Sample mean minus O plus the value from the table, then it times standard error. SE stands for standard error. And our standard error is this one. So we say multiply by this. So this will be 69.1 minus O plus. If you get this times this, what do you get on your calculator? Approximately
0.8991.
It is 0.8991.
0.8991, like this, eh?
Yes.
Perfect. So once you have that, you get your lower limit, and your lower limit is 69.1 minus 0.8991.
It's 68.2001.
68.2001.
2001.
Then upper limit. Now where you have a minus, you put a plus. This is 69.1 plus 0.8991, which is equal to 69.991. So this is approximately, if we want to make it a whole number, the lower limit is approximately equal to 68. Then this is approximately equal to 70. So finally your range will be equal to 69 less or equal to 69 less or equal to, you put in new. It means that your new can either be this one, 68. Population mean can either be 68. It should not be below 68. It should be at least 68. Then you also put less. That is the range. We are trying to get the range. That is the answer. This is what was required. Are we together, colleagues? Is there any question here? So you just need to know that's all actually. That's it. That's all. You're done with this number.
Hello.
We go to the next question. Colleagues, for Z test, someone is asking?
Yeah, I have an inquiry.
Yes, feel free.
Now, and maybe unfortunately, I didn't attend the previous one, but I wanted to.
Kindly be near to your mic.
Yes, I wanted maybe you'll clarify more on how can I be able to differentiate whether they want me to use this formula of the x bar plus or minus c squared, maybe or z, or maybe they want me to use the other formula of t is equal to r x bar minus mu divided by standard deviation. So how can I be able to differentiate which formula I'm supposed to use?
Whether to use this or the other formula. The other formula
Yes.
of x bar minus mu.
Yes. How can I differentiate?
Now you just know that every time you're looking for range, every time you're just determining, you just look at the question. We are just determining a 95% confidence of mean, of population mean. The other question will always be test a belief. They say test at 95%. You get? Here you are determining, but the other question you'll find that you are testing. When you're determining, that is range. But when you're testing, now it is a different story. you're now testing, comparing the computed value, then also the value from the table. But here, there is no testing. We are not testing any belief. That's why you see here, I have not even stated the hypothesis. But the other question where we are saying test, we will always start by stating the hypothesis, null hypothesis and alternative hypothesis. But with this one, no stating hypothesis. It's a matter of just determining range. Is it clear?
Okay. Yes, it's very clear. Thank you.
Then another thing is you just need to know that if your n is above is either 30 or above, then here where you have t test, where you have t, you must put what? Z. But I want, if you missed the other session, please go and follow that recording. It is very clear about Z test. I wanted we again do t test together. So if you missed the other session about Z test, please go and follow. Then another thing I want also to talk about is, now here we are talking about mean. You may be dealing with actually what? Proportions. In the question, you are not having mean, but you are given what? Proportions, the percentages. Now we need to look at the situation where you're dealing with when you're dealing with one proportion. Or when dealing with one proportion. You have one proportion to percentage, because sometimes you find that you are looking at two categories. You have maybe looking at category A and category B. Category A has its own proportion, then also category B has also its own proportion. But here we are dealing with one category. So let's look at the question. When you follow the other recording, you will answer. Remember I said you answer this, you also answer this. Because this part A and part B requires you to use Z test. Or you want we do call part one of the parts.
Yes, we do call one part.
So I'm going to do which part? I do part A or part B?
Part
I do part A. So let's do part A, then you will do part B. So here they are telling us that, so it means that I have to first remove this using Z test. So part A, they are telling us that a busy restaurant in the center of artisan workshops in Kampala buys fruits in bags towards festive seasons. In order to ensure the quantity of the fruits packed in the bags were accurate, here we are trying to actually see whether the quantity of fruits packed in the bags, whether they were accurate. A sample of what? 360 bags. It means that N is above what? N is above 30. So automatically, if N is above 30, or if N is 30, it can be 30 or above. So here n is above 30, automatically you use z-test. Here a sample of 360 bags was tested and it yielded a mean weight. This is a sample and it yielded a mean weight of what? 100. So this is X bar. This is your X bar and you have standard deviation direct. They are telling us we estimate. My colleague who asked, we are estimating, we are not testing. We are just estimating. Every time you are estimating, it means that you're trying to get the population mean. Estimate the 99% confidence interval, that is vertical range of the mean weight of all the bags bought by the restaurant. So we are looking at the overall mean, population mean of the restaurant. So it means that this 99% is confidence level. You need level of significance. So we do the working together. What are we given? What I need is just to copy this formula. Where is it? This formula. So it is this. Where you have T, I put Z. Other things are the same. Are we together, colleagues? Is it clear?
Yes.
Yes.
So our sample mean, that is X bar. From the question, it is what? From the question, they told us that a sample of this is going to yield a mean weight of 100 kgs. So mean is 100, then standard deviation, that is sigma, that is S. Sample standard deviation, that is S, is equal to 15.
15.
So we can first get standard whereby you get standard deviation divided by root n. This is root n. So our standard deviation is 15. We divide by root 2.
360.
Divided by root 2. N is 100. No, n is what?
No, it is 360.
N is 360. 100 is sample mean. So finally, what do you get? 15 divided by root 2, 600, so 360. 15 divided by, for you, what do you have?
0.7906.
0.06. For this question, we had variance, but the formula is this one. However, when you're given variance to get standard deviation, you take square root. So don't start asking now. Here I had to put a root, but now here I'm not putting a root. The reason is we have in this question we have standard deviation direct. So we have our standard error. We can now get Z. We can now get Z. We can now get the value, Z value. We can now get Z value from the table. But before you get that value, recall our steps. We need the significance level. And that level is what? We have in the question we have 99%. That is, the higher percentage is always confidence level, then the lower percentage is the significance level. The lower percentage is 1%, which is approximately equal to 0.01. But we are dealing with a two-tiered test. Whenever you are dealing with two-tiered test, it means that you are going to get 0.01 divided by what? By 2.
By 2.
Is equal to divided by 2. That is approximately. Now, people who are not using the calculator, how do we know that it's correct? I said that every time we are dealing with confidence interval, every time we are dealing with range, that must be two-tiered test. You will never do a question related to range and you're dealing with one-tiered, never, because for you to use one-tiered test, you must be sure the standing point. If you're saying that my mean is 100, it should be 100. Then the standing point, the alternative is either above 100 or below 100. But you see here, we don't know the population mean. Like at this point, you don't know the population mean. You don't know whether it is actually above. Actually, we can look at this. We don't know whether it is actually above sample mean. We don't know whether it is actually below sample mean. So we are not sure the side where we should stand. If we were sure that in the question they indicated that the population mean should be above 100, then you be sure the side. You cannot divide by 2 where you are sure about the side. As we are going to see some questions. But here you are not sure whether this is your sample mean. Now you are not sure. You are not sure whether your population mean is below that or above this. At this point, you are not sure. You are not sure whether it is equal to this. You are not sure whether it is above this. So that's why we are saying that with range, it will always two-tiered test. You don't have the side. So you have to divide your significance level. And what do you get now? You see people who are not using calculator in an exam, you can fail to read that value. You have 5 times 10 power negative 3 on calculator, isn't it?
Yes.
And if you have 5 times 10 power negative 3, now, if you are doing it for the first time, you start shivering. Start shivering. Now you don't know what you should record. But it means that whenever you have 10 power negative something power negative 3, it means that every time you say negative, you must first write 0, then you say point, count 3 places to write 5. 5 should, it means that that 5 should come on the third place, which is here. Are you getting, colleagues? If I thought it was 5 times 10 power negative 4, then you add another 0, then this 5 should come on what? On the fourth place. But now it is coming, this 5 should come on the what? On the third place. So we put it here. So once you do this, now if at all we are using the t-test, we stop here. The same way I said we stop here. You recall, we stop here and go to the table. But here, before you go to the table, you do another step, which is what? 0.5 with z-test. We have to get 0.5, then we subtract 0.005. 0.5 minus that, and you have 0.495. So this is like your probability. This is like our probability. This is like our probability. We want to know the value of z that gives us this probability. We want to know the value of z that gives us this probability from the table. So what is that? Yes, someone is asking. Are you asking? So we go to our Z table, Z distribution table. What are we interested in? We want to see the value that gives us this probability. So we go to our table. This is our cumulative normal distribution, and it is Z. You see this PZ. So the values you have, these values within the table, you see these values, these ones, I mean these ones, not here, not here, I mean these ones. Those values are probabilities. So you look for what? You look for where you have 495. Out of all these values, where do you find 495? So it means that I will need 49 first. 49, this is 47, I move. This is 48, I move. This is 49. Now, when I know that now I'm dealing with 49, I start now being careful. The next figure is what? The next figure is 5. The next figure is 5. This is 49. This is 499. This is 492. That's how you'll be looking for. Because you know that after 49, you need 5. But here you are still dealing with 3. You are still dealing with here now you are dealing with 4. But remember, you need 5. 4, 4. Now here you start to relax. Here you have 4946. So it means you can continue. Okay, 494, 4949. Then here you have 4951. Are you seeing that now? From this, now you start dealing with 5. You start dealing with 5. So between this, between 4949 and 4941, you need to choose one value. You need to choose. Are you going to go with this one, or you're going to use this one? Because this is 4949. Then this is 4951. Which one is more accurate? Which one is more accurate? Here you have 4949. Which one is very, very close?
It is
4949.
4949. People are saying 4949. Now, if you look at this, can you find without rounding off? Can you find 495 here?
Yes.
But without rounding off, you cannot find 495 here. But with even if I don't round off, I can find 495 here. It is within. But in an exam, examiners can mark you. If someone can decide to say, okay, me, according to me, if I round off, I can actually go with this. And another person can say, even if I round off, I can go with this. This is the more. So you just choose between this one and this, write one value. But I always advise at least choose that value where even if you don't round off, you can find there the value. Because you see like here, 4949, without rounding off, you cannot get 495. But here, even if I don't round off, already I am dealing with 495. So it is already here. So I can choose. Now, what is the value that gives me this meeting point? I ask myself, what is the value that gives me this meeting point? It is, I start from, this is Z. So that value is 2, 5. Then the column that is giving it. If you have decided to go with this one, ask yourself what is the column that is giving you this. If you have decided to go with this, ask yourself which column is giving you this. So the column that is giving me this is column 8. This is 8. So I start by writing 2, 5, then I write 8. That will be my Z value. Z value is 2.5? Is it 5? 58. Is it clear, colleagues?
Yes.
If you decided to go with this one, then you will go with what? 7. So that is our value from the table, and we have everything on our formula. So substitute and get the answer. Substitute and get the answer. This will be equal to x bar. X bar, our sample mean is 100. Then minus O plus O plus Z value is 2.58. Then times standard error. Standard error is this one. So finally, you have 100 minus O plus what? If you get 2.58 times 0.7906, I have 2.03. Now, if I round off, it is 40, something like that. Or if you want to maintain 4 decimal points, then it is 3.97. Do you have this? If you get 2.58 times this, you get this?
Yes.
So lower limit is equal to what? then upper limit. Lower limit, you get 100 minus 2.0397, which is equal to what? 97.9603, which is approximately equal to 9098, isn't it? Then here it is 100 plus 2.0397, which is equal to what? 102.0397 equal to 102. So finally, your population mean. Finally, your population mean should be in between 98. It should be either 98 or between that, but should not exceed this. So we say less or equal to nu, then less or equal to 100. You are done with that number. You are done with that part. You are done with that part A. Now you can put bags, like if you know the units here, you can put 98 here, 98 bags. These are what? 102 bags. You know the units. So the first one is Z test here. Rather, first one T test, Z test. Then we go to proportion now. We go to proportion. I believe you will answer that part B. Remember here we are just dealing with one sample. We are still dealing with one sample. So in your free time, just answer this very fast. Here you have standard deviation direct. They are telling you the mean height of the random sample, and the sample is 30. So if the sample is 30, are you using Z test or T test?
Z test.
You're using Z test. Then the average way, I have average height is this. So that is your sample mean. This is 95% confidence. That is your confidence level, get significance level. So you will handle this very fast. Let's go to part C. Part C, they are telling us that a random sample of 400 fruit juice drinkers revealed that 37% consume passion juice regularly. Find, we are not testing, we are doing what? We are just finding, we are just estimating, find a 95% confidence limits, that is interval, that is range. For the proportion, this is not the mean, this is proportion. For the proportion of fruit drinkers who regularly consume passion fruit. You see that a question is just like this, but it can be taken like 5 marks or 8 marks. So what are we given? The formula will remain the same. The difference is just getting. Also, as you deal with proportion, confirm whether you are using t-test or z-test. Even if you're dealing with proportion, confirm whether you are using t-test or z-test, because we don't have proportion table. We have a z-test or distribution, t-distribution table. So the sample is above here. Here, this is question. This question what? Is it question 3 or question 2? This is question 2. This is question 2, part C. And we are dealing with proportion, where you're given percentages. Using Z test, because the sample, because N is above 30. And what is that N in the question? What is that N in the question? N is what? Our sample is what?
80.
Our sample is 80. When you check, are you sure our sample is 80? What are you doing?
No, our
400.
sample is 400.
Our sample is 400. Our sample is 400. Then what are we given also? We are given a proportion. P, the probability of success. P, this is like the probability or the percentage. P, probability or the proportion of finding probability of success. And we are focusing on those who consume passion fruit juice. If you're given 35%, the probability is what? The probability is 0.37. What about Q? How do you get Q now? The probability of finding those who don't consume, probability of failure. Those who don't consume. Probability of failure. Those who don't consume passion fruit juice. And that is 1 minus P. Someone in the chat is saying 0.63. So this is 1 minus 0.37, and the answer is 0.63. So we have P, we have Q. What is the next step? The next step is actually to copy this formula. Because we need the population mean. But we are using Z-test to remain here. Everything, the formula is this one. But where the difference is getting, okay, let me start with sample mean. Sample mean X bar is equal to what in our question? Oh, sorry about that. Sorry. Just here you need the standard error. Here where you have X bar, this should not be X bar. This should be proportion. This should be P. This should be P. Where you have X bar, put P. That's where the difference is. Where you have X bar, put P. Then other things remain the same. Because here you don't have mean. We are actually getting, when you check the question is not taking you to the side of mean. The question is saying proportion. 95% confidence limits for the proportion, not for the mean. This is for the proportion. However much you can get mean, but you stick to what? Proportion. So our proportion, our P is 0. We have already P, which is 0.37. You can get standard error. Standard error. And the standard error, how do you get standard error now? For proportion. Now, colleagues, when you're getting standard, when you're getting standard error for proportion, get standard error for proportion, you simply get root 2. You simply get root 2. Simply get root 2. PQ over N. That is how you can get standard error for proportion. You just get root PQ over N. So our P is what? Our P is 0.37. Then we multiply our Q, which is 0.63. Then we divide by what? By N. What is our N in this question? 400. What do you get? Please do use your calculator so that you know how to use your calculator. When you are doing this, just open bracket, write 0.37 times 0.63 close bracket, divide by 400. Then the answer you get, write square root on your calculator, square root answer you get. Or if you want, you do one by one until you get the answer. First get what is up, divide by down, you get the answer, then like depending on your choice. But you need to learn how to use calculators. This paper people fail because of calculator. So what is the answer?
0.02. 0.024.
0.024. Are you all getting the same? Someone in the chat? Okay. So that is our standard error. We need the value now from the table. Z value. We need Z Z value. Z value from the table. Z value from the table. Which significance level? Significance level here is what? For this question, what is our significance level? It is 95%.
Yes.
95%. So this is 5%, which is 0.05. Okay, so because we are dealing with interval, we get this 0.5. We get this 0.5. Now get this 0.05 divided by 2, which is 0.025.
0.25.
Then you go ahead and get 0.5 minus 0.025. Then you get, oh, here you get 0.449 or 47.
475.
This is 475. So that is our probability. This is like our probability. We need the value that gives us this probability from the table. So what is Z? Z value. It will be equal to what? Go to the table and look for this. It is 475. So here you have 47, I move 475. 475 is where? Now here I have, this is where 5 starts from. Don't you say I have it direct? 4750.
Yeah.
750. So I can take
It
this.
is.
However, another person can decide to take this and add. But to avoid confusion, let's just take this direct. 1119. Then the column that is giving us this. Because this is a point where you can find actually 475. You cannot go to this side and you leave this. This is a point where you can get 475 direct. So the column that is giving us this is what? 6. So we write 1.996 as our Z. So substitute and get the answer. Substitute and get the answer. So this will be your population, your proportion. Sorry, P stands for proportion. This is 0.37 minus O plus. Minus O plus. You get the value from the table 1.96. Then multiply the standard error 0.0241. Here you get, this is 0.37 minus O plus. What do you get if you multiply? I have 0.0. like this.
7. Yes.
So finally, what is your lower limit? Your lower limit is equal to what? What is your upper limit? So lower limit is 0.37 minus 0.004. What do you get? This is 0.3228, which is approximately equal to 0.32. And in the percentage, that is 32%. Then here, this is 0.37 minus, rather plus 0.0472, which is approximately equal to what? Do you have
0.4.
0.41,
0.17.
which is approximately equal to 0.42, and that is approximately 42%. So you are here you remove the word mean. This is proportion. This is proportion. Here you are not dealing with the mu, you are just dealing with population. So finally, the range, you can just say from, if you don't want to write all those things, from 32% to 92%. That is also range, just as simple as that. Or you say, or you write 32%, then put less or equal to P less or equal to 42%. So that is actually your answer. Is it clear?
Yes.
Okay, so we can proceed to the next. If you have a question, please feel free to ask.
Maybe Mr. Abe.
Yes, you have a question?
Yes, for instance, if it's approximation proportion, am I able to determine whether the figure given in the question is true or false? What can I use to know?
You always look at this. You always look at what are they basing on? On the required part, what is their focus? Remember, to know the probability of success, we always look at the what? At the required part. They are taking you to which direction? To those who consume passion juice, or to those who do not consume passion juice? So if you confirm that actually, you confirm that actually on the required part, they are telling you that you base on those who consume, like here, those who consume passion juice, then that proportion should be P. That is your probability of success. Your focus is on this. If at all they said you look for limits for those who don't regularly consume, passion juice, then the probability of success is actually those who don't consume. Then the probability of failure will be those, because for you, you want the basis. Your P should always focus on the required part. What are they interested in should be your probability of success. Have I answered you?
Yes, so maybe just to take you back, does that still apply to the binomial thing also?
Does that still apply to binomial?
Yes, if I want to know the success and all the failure, do I still look at the
Yes,
required?
yes. That's how we always know with binomial, because we are still going that side. We will discuss that area also. But you always know that only required part, they form the picture. That required part, if they have told you focus on those who consume passion juice, then that should be your P. If they say those who don't consume passion juice on the required part, then that should be your P.
So that will mean that the first 7 is the Q. To reconfirm, for example, if that said now those who, let me see, the proportion of fruit drinkers who do not consume, that means
if at all here we had the word, for the proportion of fruit drinkers who do not regularly, if at all we had that word, who do not regularly consume, then our P would be 0.63. Then this one would be our Q.
Okay, that is clear.
Yes, this would be our Q. Then we get P. P is always based on the required part. Okay, we are done with this. Colleagues, last time we discussed this. Follow the recording. We discussed this last time. Follow that revision session 1.